Hello and welcome back. In this video we will start looking at what are called antiderivatives rather than looking at derivatives. And this is going to be the main theme for the rest of the semester, using antiderivatives, which we will see how these are used to find integrals and to find area. So to begin with, let's review taking the derivative of a rather simple function. So we have 2 times x to the fourth. Well, we know that with derivatives, we can pull a 2 out of the derivative. Any constants in there we can pull out. So this is just going to be 2 times the derivative of x to the fourth. And then x to the fourth, we have our power rule, which means that we can bring down the 4 and then raise it to the 1 less power. And if I take 2 times 4 times x cubed, that is 8x cubed. Cool. So we can find the derivative of a function like this. So then here I've asked the derivative of what function is 8x cubed. Well, I just took the derivative of this function. So the derivative of 2x to the fourth is 8x cubed. So that might be at least an answer to this. But let me show you that this isn't quite the whole story. If I take the derivative of 2x to the fourth plus 1, what happens? Well, if I have the derivative of a sum of functions, I can take the derivative of both of them individually. So here I've got the derivative of 2x to the fourth, which we already computed is 8x cubed. And then the derivative of 1, well, 1 is a horizontal line, and it has slope 0, so the derivative of any constant function is just 0. And what is 8x cubed plus 0? That's just 8x cubed. So the derivative of what function is 8x cubed? Well, we found 1, 2x to the fourth, but also the derivative of 2x to the fourth plus 1. The derivative of this function is 8x cubed. And it doesn't really matter what this number is here, because as long as it's just a number, as long as it's a constant, its derivative is always 0. So here, the derivative of 2x to the fourth minus 7, well, that's just the derivative of 2x to the fourth minus the derivative of 7. And again, the derivative of any number, of just a constant, is just going to be 0. So here, I've got 8x cubed again. So I can keep writing down whatever constants I want. I could add 1 to the function, I could subtract 7, and essentially the way that we would write this down is I can take the derivative of 2x to the fourth plus any constant, which I'll just call c, and I should get 8x cubed. So again, if I take the derivative of a sum of functions, it's just the derivatives of each of them added together. And since c is just a number and it doesn't depend on x, it's not a function, it's just a constant, I'm going to get 8x cubed. So the best way to write down what is the derivative, so the derivative of what function is 8x cubed, well, all of these are perfectly good examples of functions. If I wanted to be complete, I would say it's going to be 2x to the fourth plus any number I want, plus c. So this is what we'll be doing a lot of in this chapter. Instead of asking to find the derivative of a function, we'll ask what function's derivative is equal to this. So this is why we call it the antiderivative. We're going backwards. Instead of being given a function finding the derivative, we're given the derivative and we want to find the original function. But constants will come up, so we just have to take that into account. So here's our notation. Normally we use capital F and little f for a function and its derivative. So here we have some function which is capital F, and if I take its derivative, I get little f. So I'm going from f of x and I'm taking the derivative. So like the derivative is going from capital F down to little f. But I want to go backwards, I want to start with little f and figure out what capital F is, and that is the antiderivative. So the notation for derivative, I can either use a prime, or the other notation is d by dx of f of x is equal to little f of x. This notation is called the antiderivative, and there's two parts to this. There is this funny looking, almost like an S symbol up front, and this dx out here in the back. Both of these are very necessary, and the answer here is, what is the antiderivative of f? Well, for going backwards, we should get capital F of x. But if I take the derivative of this function plus a constant, well, the derivative of a constant is always 0. So I don't know what constant should be out here. So when I take the antiderivative of little f of x, I get capital F of x plus c. Plus c is very important. Almost every single homework assignment in homework 19 will require that plus c, otherwise it'll count it wrong. Simply because the derivative of a constant is 0, so if I take the derivative of this guy, I get f of x. You need that constant there, because we don't know which constant is the correct one. So the power rule for derivatives, let's look to see how we might undo this for antiderivatives. So for derivatives, if I take the derivative of x to the nth power, this is again something that we've been doing for a while now. We pull down the n, and then we raise it to the 1 less power. Okay, so we pull down the n, and then we raise it to the 1 less power. So it's a very particular order there. The power rule for antiderivatives, we should undo, or essentially do the opposite of this. What am I trying to say? The opposite of this operation. So instead of pulling down the power first and then raising it to the 1 fewer power, what we're going to do is we're going to raise it to the 1 bigger power. We've got to go in reverse. And then, rather than multiplying by n, we're going to divide by the exponent. Okay, so we have 1 over n plus 1 times x to the n plus 1 power. And let's do some examples of this. So again, we raise it to the 1 bigger power first, and then divide by that power. So let's look at the antiderivative of and I've already done the one thing that I've told you not to do. We've got to add a c. Very important. I will always forget this. Please remind me. Just scream at the computer if you ever see me not put a c down. So we have the antiderivative of x to the 3rd. Okay. So using our rule, what we'll do is we'll take x to the 4th. We'll raise it to the 1 bigger power, and then we'll divide by that power plus c. Easy peasy. Let's check to see if we did this correctly. How do you check an antiderivative? Let's take the derivative of this guy. So what happens if I take the derivative of 1/4 x to the 4th plus c? Well, the derivative of 1/4 x to the 4th, I can pull out that 1/4. I bring down the power, and I raise it to the 1 less power. And then the derivative of the c, oh, that's just 0 at the end. And what is 1/4 times 4? That's just 1 times x cubed. Oh, hey, look, we got the right answer. And again, I'm being a sloppy mathematician here. I can't forget both parts of the symbol here. We've got the integral symbol and this dx at the end. I have, oh, never mind. I wasn't being sloppy. I don't have to put the dx in there. Never mind. Let's keep going. I'm just being a bit silly. Let's take the antiderivative of 1 over x to the 2nd power. And first of all, I want to write this as just something as x to a power here. So I'm just going to rewrite this ever so slightly. So this is the antiderivative of x to the minus 2 power. So all I'm doing is I'm taking x to the minus 2 rather than writing as 1 over x squared. And again, here I've got x to the nth power. So this is going to be, I'll raise it to the 1 bigger power. So 1 more than negative 2 is negative 1. And I'll divide by that. And then I will add c. And here, what we'll do is 1 divided by negative 1, well, that's just negative 1. And negative 1 times anything is just add a negative sign. And in fact, let me rewrite x to the negative 1 as 1 over x. So 1 over negative 1 just becomes a negative sign, and x to the negative 1 is just 1 over x plus c. So there is my antiderivative. Let's do a couple more. Again, here I've got the integral of 1. And 1 doesn't look like it has any x's in it, but I can write this as x to the 0 power. Anything to the 0 power is 1, other than 0. So x to the 0 power is going to be 1 dx. So again, what I can do is I can raise this to the 1 bigger power. Well, 1 bigger than 0 is 1. And I need to divide by 1. And I need to add c. But 1 divided by 1 is 1. 1 times anything is whatever that is. And x to the first power, that's just x. So there is my antiderivative of 1. And let's do one with a fraction in it as well. So I've got x to the minus third. So again, I'll raise it to the 1 bigger power. So 1 more than negative a third is going to be 2/3, I think. If I take 2/3 and I subtract 1, yeah, I'll get negative 1/3. Okay, so that looks good. And then I'll take 1 and I'll divide it by this power. Well, 1 divided by 2/3, this is just the reciprocal. I also can't forget my c. So this is going to be 3/2 x to the 2/3 power plus c. Again, plus c. I can't forget my plus c there. And I've told you all this. There's one thing I have to mention. The power rule for antiderivatives works for nearly all. What am I trying to say? Nearly all n's, except this doesn't work. For n is equal to -1. So we will actually see later in another video what the antiderivative of 1 over x is, as in x to the -1. This does not follow this rule here, so we can't apply this rule there. So this works for anything, any power of x that isn't just x to the -1. And I think in the next video we will start looking at more rules for antiderivatives.